very scattered in a lot of different ways, but when I am doing research, I go through equations and figure out how to calculate something interesting about dark matter. So it's really a lot of talking to people, a lot of sharing ideas, and then a lot of writing code and doing calculations. Everybody wants to find the theory of everything, right? But you have to study a small part of the theory of everything. You have to be able to test some questions. Ask some question. That question has to have an answer, and you have to show that you can find that answer. So it's really a matter of thinking about trying to balance those things. The high impact of if we find the solution versus is this actually something we can realistically test. What I do is I talk to the theorists and I try and figure out what the interesting questions are in theory and what the new models say, and then I talk to the experimentalists and the observers and I figure out what can be tested at the moment with the technology we have, what the new technology coming up will be, and I try to find interesting ways to connect the theory to the experiment and observation. So it's a very creative space to be in.
Science thrives in the world of the precise.
Okay, so let's do this. I've got SFR. So this is my gravity sector, except that now I have the Ricci scalar multiplied by some function of my scalar, which could be the Higgs, whatever. And then I'm integrating that over all space. And I also have to multiply by some normalization factor, square root of negative g, which is just accounting for, what is that accounting for? Okay, so just the way that the coordinates vary from point to point, so they could change in length. Okay, good. I need one copy.
In physics, a theory is a story told using maths. A story about how the world might be or about how something might work. And so that's how I think about, the models that I'm working with. There's stories told using equations about how the universe might behave. Maybe the story claims that something will happen. If I do X, then Y will occur. And so the aim of the experiment is to say, okay, well, let's do X and see if Y occurs. So it's putting those stories to the test and seeing if they kind of hold water. A really nice thing about physics is that, you can check whether things make sense. What do my equations predict? Okay, and I have physical expectations about what will happen, and I can check those against the equations. So a lot of time is spent just doing those checks. Sometimes when you're doing math, it's sort of in the dark, like you don't really know what's happening. It can be hard to check, but in physics, there's a really nice battery of checks that you can use to see if the math makes sense.
It takes a lot of effort for an obsessive mind to accept the fact that everything is in order except itself. Modesta darling.
I never coloured in the lines. Did you colour in the lines?
Yeah, I did. Yeah, I'm a scientist, mate. I'm a scientist. I absolutely coloured in the lines perfectly.
Not only did I not care about colouring the lines, I almost felt a fear of colouring in the lines because I didn't want to fit in. That was something that drove me.
Isn't that fascinating, though, that you were scared about fitting in and colouring in the lines, whereas I was scared of going over the lines because I knew that to do things right, in my view, I had to learn the rules. How can I be sure I'm asking all the right questions to cover all the different things that might be affecting this, this environment that it's about being out in this natural world and just looking with amazement and thinking, wow, this is all going on every second, every minute of every day, whether I'm there to watch it or not. This is all going on, and I'll never fully understand it, and it blows my mind.